Hi guys, my name is Bas and welcome to episode number 24 of my SPSS tutorials here on YouTube. Today we're going to take a look at a whole new topic, being the factor analysis. You should do this factor analysis like at the start of your complete thesis analysis together with a reliability analysis. And today we're going to take a look at the basics from it. It's quite an extensive topic with a lot of different things you can look at, for example the Bartlett's test of sphericity, but we're not going to do that today. We're going to take a simple look at what exactly is a factor analysis and how can you get to the most important values you should look at your analysis. And I've got over here a fresh new data set for us to look at, and we're going to take a look at 10 different items today about work motivation. And there are 5 extrinsic motivation items. For example, I earn a lot of money from my job and I get paid vacation. And there are 5 items which should measure intrinsic motivation. For example, I feel like I have a purpose in life when I work and I can develop my personal goals, stuff like that. And those the first 5 items about extrinsic motivation should theoretically and only measure extrinsic motivation, just as the 5 intrinsic motivation items should only measure intrinsic motivation. But in SPSS, it often turns out, you didn't know that before you made your survey, but while doing your research you can often find out that there are items which measure, so which load on the wrong dimension. So it could be the case that intrinsic question number 1 measures intrinsic motivation and extrinsic motivation. And that's a problem, because if you're then afterwards going to turn those 5 into one whole extrinsic motivation variable and those 5 internal items into an intrinsic motivational variable, then and if you're then going to compare those and make analyses with these, then it is very, very invalid if they consist of items which measure both camps. So that's why you're going to do a factor analysis to find out whether the items only measure the dimension, so the components, which they should. And that's what you're going to take a look at today. So you're going to go to Analyze, Dimension Reduction, Factor. Then you select the 10 items, in this case external 1 until external 5, and then intrinsic 1 until intrinsic 5. So you've got these 10 variables. You can leave descriptors as it is. At extraction you can leave it as it is. I've just selected scree plot, but there's no need to. You can leave it as it is. Rotation is important though, and that's that you select direct oblimin and select delta 0, but it's always 0, so you can leave that as it is, but you need to select direct oblimin. Scores you can leave as it is, and finally options you can have to press at the bottom suppress small coefficients, so you need to select this box, you need to tick it, and then select a value under which small coefficients are suppressed. And this means there is always, items are always gonna load, so correlate very little with another dimension. It's impossible if they wouldn't. So it's not bad if, for example, if intrinsic number 3 loads a tiny little bit with the external dimension, that's not a problem at all. Because if you would then need to take it out, then you wouldn't have any items left. It's only a problem if it loads on the wrong dimension by quite much. So you can select a value below which the correlations, so the eigenvalues, aren't shown. And I personally like to select 0.20, but make sure that you know what value this should be. There's no benchmark for it. You could also select 0.30 or 0.10 or even 0, so that you see all the values. But I like to choose 0.20, but make sure that you know what this should be. Then you press continue and then you press paste. And if you didn't have a syntax opened already, then one will now. Then you select the lines of the factor analysis and press the big green play button, which is run selection. and then the output screen will open. And you can first take a look at the second table, which is total variance explained. And over here we can see how many dimensions SPSS has found. And you can take a look at the number of components with complete lines. And we can see here that it has found 2 dimensions, so 2 components, which is perfect because there's one component which should measure intrinsic motivation and one component which should measure extrinsic motivation. If there would only be one component or 3 or 4 components, then you would be in a bit of trouble. We are going to leave today the component matrix for what it is, and we're going to take a look at the most important matrix, which is the pattern matrix. And this shows to what extent an item loads on a certain component, so on a certain dimension. So you can see that all the extrinsic items load on the second dimension, so therefore you can make the conclusion that the second component, so the second dimension, is extrinsic motivation. And you can see that the 5 intrinsic items measure on the first dimension, so therefore you can conclude that the first dimension is intrinsic motivation. And then if you take a look at the 5 intrinsic motivations items, you can see that they only load on dimension number 1, which is perfect, which means that they only measure the dimension they should. Well, if we take a look at the extrinsic motivation, we can see that item number 4 and 5 measure both intrinsic and extrinsic motivation, and that is invalid, because if items measure both variables, then if you're then at the end gonna make analyses with these 2 variables, it would become invalid. So we're gonna take a look at their values, and especially item number 5 loads for 0.334 on the wrong dimension and only 0.250 on the right dimension. So it loads more on the wrong one than on the right one. And that's a problem. So therefore your conclusion would be, okay, extrinsic item number 5 is invalid, so I'm not gonna take it along anymore. Which doesn't mean that you should in your data set immediately remove and delete everything from extrinsic motivation number 5. No, it simply means that in our further analyses, we're not gonna take it along anymore. What we're now gonna do is a new vector analysis with the 9 remaining items. So you go to Analyze, Dimension Reduction, Vector, and take out extrinsic item number 5. Then you press Paste again, you get a new syntax line, you select the line and press Run Selection. Then you can see that there are still two components, so 2 dimensions, and we can leave the component matrix for what it currently is, and we're going to take a look at the pattern matrix, and you see that over here there are still 2 dimensions, so 2 components, external 5 has been removed, and we can see that extrinsic 4 still loads sadly on both the correct dimension and the wrong dimension. And if you're doing a course for uni or for school on SPSS, then you would need to remove extrinsic motivation number 4 as well. Then if you're just doing a school assignment or uni assignment, then you always need to remove the items which load on both dimensions because they're invalid. So then you would do another vector analysis without extrinsic 4, and then it would show that the items only load on their right dimensions. And then you can conclude that the extrinsic dimension consists of only 1 to 3, 1 until 3, and that the intrinsic motivation consists of the 5 right items. And then you would do a reliability analysis with these items. I've explained the reliability analysis, I think, in episode 7, somewhere around that. So take a look at that episode if you want to know how to do reliability analysis. But here comes the tricky part. Most of you will probably not be doing a school course, but are working on your master thesis. And here comes and this is the most difficult part, because you probably found the items from an existing skill out of scientific research, out of a scientific research paper, which means that the skill of items is statistically correct. And by removing the items, so we've just removed item 5, and then you can remove item 4. By removing these from a proven scientifically correct skill, you are, that's not a very good scientific thing to do. So you would need to make a decision. Do I want to worsen my theoretical, do I want to be statistically a bit more invalid by still leaving item 4 in? Or do I want to worsen the theoretical part of my research? Because if you're going to take external 5 and external 4 out, then you're like playing with the theory you found and which has been scientifically proven. So this is a tough dilemma. I don't have the answer to it. My personal advice would be, like, external 5 loaded more on the wrong dimension than on the right dimension. So in my opinion, you need to take it out because it's a bit of a problem. Well, external 4 loads a tiny bit on the wrong dimension and a lot on the right dimension. So I would leave external 4 in if you're doing your thesis. But this is not a definite answer. And the best thing to do is just discuss this with your thesis coordinator, because I don't have the right answer. There is no right answer. You need to make a choice, and you need to insert this into your discussion. Like, I chose to keep the invalid items in, or I chose to remove them, and thereby not sticking to these theoretical skill I found. So you need to whatever choice you make, you need to insert that into your discussion. And but once again, if you're just doing a school assignment or a uni assignment, like a small one, then you have to take out number 4 as well. That's basically the most of the times the assignment. So this is the basics of how to do a factor analysis, and I hope this was helpful to you. I will be back with more videos on the more difficult topics of the factor analysis, but this was the basics for it. And I hope this was helpful. If it was, then please leave a like and subscribe to this YouTube channel. I want to make SPSS grow as much as possible. And I will be back later with more videos, but for now I'm out. Bye.